Okay, so we hear all the time about how AI is getting bigger and bigger, right? But what if the real game changer isn't about size at all, but about how we actually teach these things? Today, we're going to dive into a really cool new method that could take AI from just, copying what we do to genuinely reasoning on its own. So let's kick things off with a puzzle. And it's one you might have bumped into yourself. You've got these incredibly powerful AIs, these large language models that can churn out poetry or write complex code, and yet sometimes they just stumble on basic common sense stuff. Why do they feel so, well, fragile? Well, the answer really starts with how most of these big models are trained. And at its heart, it's basically a giant game of imitation. I love this analogy. Imagine you have a brilliant chef, but their only training was to memorize millions of recipes, word for word. Sure, they can replicate any dish they've seen perfectly, but what happens when something goes wrong? Can they fix it? Can they innovate? Nope. This is kind of what's happening. It's a rigid copycat method that forces the AI to just follow static examples, never really learning to think for itself. And this creates this huge gap. Researchers call it the training generation gap. Basically, the AI is totally comfortable with stuff it's already seen in its training data. But the second it has to step out into the messy, unpredictable real world and generate something new, it struggles. And that's what's holding back its true problem-solving power. Okay, so what if there's a better way to do this? A way that's less about memorizing a cookbook and more about, actually learning how to cook. This is where something called reinforcement learning, or RL, comes in. Now, instead of just memorizing, we let our chef get in the kitchen and actually cook. They try things. They get feedback, a reward, basically, for what tastes good and what's, well, not so good. They learn from trial and error, from the outcomes of their own actions. And that's how you get real creativity, not just mimicry. And this really gets to the heart of why RL is so much better. It basically builds a bridge over that training gap we talked about. Since the model learns from what it produces, it's not chained to some static dataset anymore. It can explore, it can experiment, it can find all sorts of solutions that weren't in the original textbook. Okay, so if RL is so great, you're probably asking, why aren't we training every AI this way? Well, it comes down to a massive, and I mean massive, data problem. A huge bottleneck. This really lays out the problem perfectly. On one hand, you have the data for regular pre-training. We're talking trillions of tokens. Think of them as little pieces of words just scraped from all over the internet. It's everywhere. But on the other hand, for RL, you need that special feedback data. And that stuff, it's super scarce and really, really expensive to create. And this chart, wow, it just drives the point home, doesn't it? The data for pre-training is that giant skyscraper on the left. The data we have for RL, it's that tiny little building next to it. We're talking a mountain versus a molehill. RL has basically been starved of the fuel it needs to really take off. So to put a number on it, we're looking at a 100-to-1 data advantage for the old way of doing things. This gap hasn't just been a small problem. It has been the single biggest thing holding RL back from making our AI models way, way better. That is, until now. So how do you break a bottleneck that huge? This is where we get to the really exciting part. A breakthrough innovation, a super clever pipeline that's designed to do a kind of digital alchemy, turning all that messy, raw web data into pure gold for reinforcement learning. A team of researchers from Salesforce AI and Carnegie Mellon University came up with this. They've built what you can think of as a data refinery for AI. They've basically cracked the code on how to take that gigantic, messy pile of web text and automatically turn it into high-octane fuel for RL. So how does this data refinery work? It's a pretty elegant four-step process. First up, it cleans everything, filtering out all the junk from the web. Then, and this part is just genius, it assigns different personas to a document. So imagine it reads a medical article. It'll then generate questions from the perspective of a doctor and from the perspective of a patient. This creates this amazing diversity. Third, it cooks up verifiable Q&A pairs based on those personas. And finally, the all-important quality check, to make sure the answers are right and the questions aren't just giving everything away. And the final product? It's a brand new data set they're calling Webscale-RL. And the key thing here is that it's not just big. We're talking over 1 million examples. It's also super diverse. Because it comes from the web, it covers everything from math and science to coding and commerce. All these areas where good RL data was really hard to find before. Okay, so the pipeline creates all this amazing new data. That's great. But the million-dollar question is, does it actually lead to a smarter AI? Well, the results are pretty convincing. All right, let's look at the data here. The row you want to focus on is the bottom one, for Webscale-RL. Now, just look at the average score on the far right, 52.1. It clearly beats the other methods. But check out the Math 500 column, a jump from the mid-40s all the way to 58. That is a huge leap in the AI's ability to handle math problems. So yeah, that performance boost is amazing. But honestly, that's not even the most incredible part. The real magic is how much more efficient this whole process was. Get this. The research showed that training with this new RL data could get you the same level of performance as the old way, but using up to 100 times less data. Think about that. This isn't just about saving some computing time. This makes building powerful, smart AI models way more accessible to way more people. Okay, so let's zoom out a bit and think about the big picture here, because this is way more than just one new dataset or one clever trick. What we're really looking at is a viable path forward, a way to finally scale up reinforcement learning to match the massive scale of pre-training. By closing that huge data gap, this work basically unlocks the true potential of teaching AIs to learn from feedback. It's a recipe for more capable, more robust, and just plain smarter AI. So by finally cracking this data problem, we're giving AI the tools to move beyond just being a parrot and start becoming a genuine problem solver. And that really could change everything. Which leaves us with one big, exciting question. Now that we can do this at scale, what problems are we going to solve next?